This is a podcast on the vacuum flask, and I'm using the questions that we've got in a test to go through those. And the most important thing to remember is that this is about heat transfer, and so you should be looking in this answer to give the facts of the whats and the whys of heat transfer. And a vacuum flask is a very clever piece of kit because it tries to stop heat transfer on pretty much all levels. Okay, so of course the first thing to remember is that we've got three types of heat transfer. We've got conduction, and we've got convection, and we've got radiation. And in terms of these, we are going to look at the vacuum flask, and the first question here is give features of the flask which reduce the heat loss by conduction. Now, reading the question here, it does say features. And features is an important word here because it's got an S on the end. Features. So don't just think that you can just say one thing and that's going to be enough. And the other thing is, there aren't any marks here, but if this had, say, 4 marks next to it, then you could be sure that you needed to make 4 points. So remember when you're answering questions, either to give all the information you can, if there's no marks there, but actually in the GCSE there will be marks, but in this type of question, give all the information you can. And if there are marks there, be guided by how many points you need to do by the number of marks. So, conduction. Well, looking here, we've got a stopper. And a stopper is made of rubber or plastic. And that should be telling you, that's a good insulator. Now, all plastics and woods and things like that are good insulators. And insulation is the opposite of conduction, isn't it? If you are a good insulator, you're a bad conductor. If you're a good conductor, you're a bad insulator. So the very fact that this is an insulating material means it must be a bad conductor, so it must be stopping conduction. So the first thing to say there is that our rubber stopper is a good insulator, therefore prevents conduction. Then looking at the rest of the vacuum flask. Well, this is glass walls, and the glass walls are a poor conductor of heat. Glass is not a great conductor compared to, say, metal. And so the glass walls, to a certain extent, would prevent some conduction. But it's not the best it could be. So I would mention that glass is not the best conductor, but it's not the be-all and the end-all for conduction. And the other thing, though, is imagine if any heat does escape through the glass here, through conduction. It goes into this outer casing, and this is usually made of plastic. Okay, you can think of a thermos flask. Now the plastic will be there for a couple of reasons. The first is that it offers protection because you've got glass inside, so you want to make sure that it's cushioned. But the second is plastic is a bad conductor. So if it's losing less heat out to the outside, then there's going to be less heat traveling all the way through. Okay, so the plastic casing as well is another thing that helps prevent conduction. Now, we move on to question 2, which is convection. Now, convection, as we know, is all about air currents or fluid currents. So it could be a liquid, could be a gas, where the hot air goes up, and then once it cools, the cool air comes down. The cool air or fluid takes the place of the one that's gone up. Remember, we like to say that the reason it rises is because it's less dense. Okay, whenever you're talking about convection currents, mention less dense. And we need to look there where fluids might be allowing heat to escape. Well, if we look at this, we have a situation here where we've got a vacuum in this area. Now, a vacuum actually means that heat can only transfer via radiation. So looking at this, if there is no air in here, there can be no convection current set up. So the vacuum in here means that convection is stopped happening. So the vacuum is a huge element. But can you see, in fact, what I've done here? I've actually probably missed out the vacuum for the first question here, Because if only radiation can travel through a vacuum, then as well as convection not being a possibility, conduction is not a possibility either. So in fact, we had the stopper here for conduction, and we had the casing, so I'm trying to write sideways. But we can actually add the vacuum too. Because if nothing can conduct through a vacuum, that is going to keep the heat in this area. So the vacuum is very useful for both conduction and convection. The rubber stopper, a number of people mentioned the rubber stopper preventing convection. I suppose it does stop air going out here and allowing heat to escape that way, so maybe. But I think it would be more the vacuum here that is the key. Okay. Now, the last one is heat loss by radiation. Now, radiation can go through the vacuum. So that is a problem for us, because that means that that is not going to be a particularly useful thing, having the vacuum to radiation. And so I want you to think about the glass walls. The glass walls are actually shiny. If you've looked inside a thermos flask, you'll see that they've got shiny glass walls. And that reflects the heat back in. So if the heat hits the glass wall, it will be reflected back in, so it won't escape. So the shiny glass walls are the feature that the thermos flask has to prevent radiation. The other thing is that on the outside of this thermos flask, we have usually a shiny plastic surface. Now, shiny surfaces are poor emitters, and emitters means to send out. Mitto in Latin is I send, and e is out of or from. And they are poor senders out of energy. So this shiny, nice plastic is not going to send heat out. Okay. If it was a matte black surface, and you don't see any matte black thermos flasks, you would actually feel more heat being transmitted and emitted out. And so the shininess, any shininess, is something that prevents radiation. Okay? So they are the features of conduction, convection, and radiation. Last thing to say about this question is don't be drawn into just putting all of them for all of them, because you won't get the marks. You need to be selective. What is it that stops conduction? What is it that stops convection? What is it that stops radiation? Okay? And if you feel that there's only one or two on each one, just write one or two. If there's more, write more. Okay? But you can be guided by the numbers of marks. In that respect, this was a tricky question. And obviously when I was looking at it, I forgot the vacuum affecting conduction as well. And so always double check and think, have I covered everything? And remember, every feature of this is going to be there for a reason. And so have you, for example, mentioned the vacuum? If not, what does the vacuum do? Have you mentioned the glass walls? Have you mentioned the stopper? But that is the vacuum flask in terms of conduction, convection, and radiation, in terms of these questions that we had in the mini test. Any questions, do email me.